Hello, what's up guys? Welcome back to another tutorial about autopilot, autopilot and PX4 simulations. In this episode we are going to talk about PX4 hardware in the loop simulation using Gazebo, jMavSim and Explain simulator. We are going to I'm going to present the simulation, hardware in the loop simulation for a multi-rotor and fixed wing, but you can do it on any uh, vehicle that you have, such as rover, VTOLs and any other aircraft. So without talking too much, uh, let's continue with the topic. Autopilot has stopped supporting hardware in the loop firmware several years ago. So there is no hardware in the loop firmware anymore for autopilot because they have said that the limitation of serial communication has degraded the performance of hardware in the loop simulation. And I think they are doing a good job because it's really bad when you're using hardware in the loop with the real pixel on your board. Usually, especially if you are using a heavy program such as Explain that you need to transfer many data. But anyway, PX4 still support this feature. You can use it, and it's kind of much more realistic than software in the loop. But depends on your work. Software in the loop may be enough for you, so you don't need hardware in the loop. But let's talk about it more. Without much more talking, let's continue to the concept of hardware in the loop. So, what is hardware in the loop? Remember in the last episode we had software in the loop. With software in the loop, everything was happening inside your computer, inside your laptop, inside your PC. The model, which runs in Gazebo, Explain, or any other environment, and the controller, which was Autopilot or PX4, were running inside your computer environment. But with hardware in the loop, you're going to run the controller inside the hardware itself. So you need a physical pixel in your hand. You need pixel that all the sensor data are being fed from the simulation model to pixel. Pixel process everything and send back the actuator's command back to the simulator. This is hardware in the loop. It's kind of much more realistic because your code is being run on your in your microcontroller inside your programmer, inside your controller board. But depends on your work. You may don't need hardware in the loop at all. That's the point. That depends on your project. You can use hardware in the loop for PX4 on different simulators such as Explain and mm, Gazebo. I'm going to talk about it more when we dig into the work. In this picture, you can see two different implementations. This is the architecture behind the hardware in the loop workflow. Uh, that what is happening behind the scene. For example, on the left, you see how PX4 handles hardware in the loop when you are using jMavSim or Gazebo. You see that the hardware itself communicates using serial communication using Gazebo or jMavSim. Then it communicates with UDP using QgroundControl. And also you have joystick controller connected via USB serial. But on the other hand, when you want to use Explain, you see the hardware is communicating using serial to the ground station software. So hardware is connected directly to the ground station computer, and then the ground station computer communicates to Explain using UDP. So in the left, PX4 is communicating directly to simulator and then simulator to ground station controller. But in the Explain simulation, the hardware communicates with ground station controller, then the ground station controller communicates with Explain simulator. It's kind of different because it's because of the capability and different options that developers had when they are dealing with jMavSim and Gazebo and Explain, because Explain only supports high-speed communication with UDP. I guess it might be the reason. But let me clear something here. Hardware in the loop with Explain it's kind of challenging. I have faced with many errors, many bugs, maybe some of them because of my poor performance computer that I have right now. maybe it is really bug. If you search internet, you may find many problems about this. Many people are arguing about the problems and bugs. So don't rely too much on hardware in the loop with explain. Or if you have any idea and think I am wrong, please tell me so I know the solution for the problems in this video. But in the other hand, I rely on hardware in the loop with jMavSim and Gazebo simulator for Quadrotor. That's great. That's very fast and great. Maybe because the simulator is directly communicating with the hardware, but in the explain, there is something behind them which is the ground station control. So ground station control may create a lag in this data flow. This might be the reason, I don't know. Okay, let's stop talking and go to the work and do something great. And okay, the last thing before starting the work I forgot to say is that what do you need? What do you need for this? Actually, as I told you, it's a hardware in the loop, so you must have a PXAC hardware. APM doesn't work because it cannot support PX4. You need a PXAC. Mine, for me right now, mine is the first version of PXAC, the old version. And you have to install PX4 on that, not autopilot. You may need a radio controller and receiver if you want to use the radio controller, especially if you're going to use X-Plane, because I don't know, for some unknown reason, X-Plane throttle control only take control from RC control. I don't know why, and I don't know the solution. If you know, please give me the answer in the comment. And if you don't have radio, you can still work with joysticks. If you have joystick, you can connect a joystick. And you need definitely you need a laptop to do the simulation. That's it. That's all the things you need. The most important one is the PXAC itself. You must have the PXAC. Okay, without more hesitation, let's go to the. Okay, this is a page that my tutorial is based on this page. I put the link in the description. You see here the brief introduction of hardware in the loop. You see that different simulators support different vehicle. For example, for a standard VTOL, you have only option to use with Gazebo. I couldn't do that because it's a little bit hard for implementation, but it's possible. You see, when you know the concept, you can implement each one you like. We are going to use implement the Quadrotor X here. That you see, we can implement it with Gazebo and jMavSim. But it doesn't mean that you cannot use Explain. It is possible, but you have to create plugin and APIs between the wave by yourself. These are the implementation that we already talked about, and the difference between the architecture and the comparison between hardware and software in the loop. The real work starts here. Okay, let's start. The first steps happens inside the QgroundController. We want to run with Gazebo and jMavSim. I run the latest version of QgroundControl, and we have to do some settings. I connect my PXAC controller first using serial. I have disabled the auto connection, so I connect it manually. You connect your PXAC to your computer using USB. If you haven't already installed PX4 firmware, just come to the setting and firmware, do as it says to you, and install the latest version. Okay, firmware is uploaded, the board will be restarted and ready to continue. Next step is to come and selecting the airframe that we want to use. We go to the setting tab, airframes, and select the airframe we want. In this case, we are going to use HITL Quadcopter X, hardware in the loop Quadcopter X. This airframe is optimized for using with hardware in the loop. You can use any other airframes, but you have to do the settings and maybe create some plugins or do some codings for that. I don't know. Okay, when the board restarts, it again connects using serial. You may need to do some settings here. For example, we go to the safety and we should enable the hardware in the loop. if it's not already selected. And remember, when the hardware in the loop simulation finish, come here and disable the hardware in the loop and disable the RC, the different failsafe, because maybe your radio will stop somewhere, so you have the radio capability and your vehicle won't come back. You let that to sometimes lose radio signal. Then if you are using radio, come here and calibrate your radio. Very straightforward steps. Calibrate your radio. If you are going to use joystick, you can use joystick for Gazebo and jMavSim. You have to go to parameters and change the settings for using joystick. This is the flight mode. You can assign one of the channels of your radio for changing the flight mode. No need to worry about the power settings because we are not using any battery here. If you are using joystick, you should come here to parameters and change the main source from RC to joystick without RC check. And if you do that, another option will appear to calibrate your joystick instead of your radio. Okay, one more thing to do in settings, because as I told you, when we are using jMavSim, we are connecting to QGround using UDP. So we stop QgroundControl to connect automatically using USB. It should connect using UDP. So we unchecked everything except the UDP. Okay, we have done everything here and we don't need QgroundControl anymore right now. I close it. Next step is with building the PX4 environment for hardware in the loop implementation. If you have seen the last episode of my tutorial, you already have a PX4 firmware inside your computer, but I totally suggest you to clone a new version of PX4 because you might change some settings when you're using hardware in the loop that may make you some troubles doing software in the loop in future. So make a new directory. You see, I have already created a directory for myself, a PX4, a normal PX4 and PX4 HIL. So you go ahead and make a directory and call it PX4 HIL, then cd to that PX4 HIL. Then you can clone a new clone of the GitHub repository of PX4 firmware. Very simple and straightforward. Copy and paste the repository URL. You have already done all of these steps if you have seen the last videos. Git clone and the URL. It might take a few minutes if you haven't downloaded. I have already downloaded. When it downloaded, cd to that folder, cd to firmware directory, and you are good to go. Okay, let's go back to the documentation. We cd to the firmware and we run the software in the loop make, because somehow we want to create the hardware in the loop communication implementations. So we are going to use software in the loop make. I don't know why they call it software in the loop. Maybe they have some common things between themselves. So when you make the software in the loop, it also makes something for hardware in the loop as well. Before that, do make clean to make sure that you haven't ruined anything. So we have to wait until the make complete. Before that, we have to change some line of codes inside the model file. Depends on which airframe we're going to use. Right now we are using a quadcopter airframe called IRIS. If you are going to use another airframe, it's different. Go to your PX4 HIL directory that you have downloaded into firmware, tools, and we go to software in the loop Gazebo and models. Look for the model you want to use here. We are going to use IRIS as the default one. There is a file called iris.sdf. Open the file with any text editor you have. So now I open the iris.sdf. Look for the type for mavlink interface. And there are 3 lines of code you should consider changing. First one is serial enable. You can change it to true or 1, doesn't matter. Both of them are 0, you change it to once HIL mode and serial mode. For serial device, usually the default one will work. This is TTYACM0. This is the COM port name. Usually it will work unless you have another device connected to your computer when you connect the PXI. To make sure, you can copy and paste this command in your terminal to make sure when your PXI is connected. Connect your PXI first and then check if you have any other things. The last one here is ACM0. This is the PXI and this is the one you should have here. Okay, we're going to next step, which is setting up the environment variable, and it's being done automatically by running a bash file. Just copy and paste for the default one, and then we run the gazebo in hardware in the loop mode. Make sure your PXI is connected to computer and let it time to boot up before running this command. My PXI right now is connected and it's booted up and it's ready to continue. Okay, the next step. Right now PXI is connected to Gazebo. Sometimes Gazebo may not load up, just close it and open it up again. Next step is to open the QGroundControl or any other ground station that you like. It should automatically connect via UDP this time, not serial. Make sure you are not connected in serial. You should be connected via UDP. Okay, that's great. We are connected. Come to the main screen. If you see the sensor is not calibrated, right now it's not calibrated, but it's not terrifying. Sometimes you open it and see, oh, the attitude is rotating, ground speed is 50 meter per second. That means there is something wrong with the sensor. Disconnect your PXI, close everything, connect your PXI again, and do everything again to calibrate the sensor. I don't know, sometimes it happens. Maybe it's a bug, maybe, I don't know. Okay, now we are connected. I'm going to arm the vehicle and I'm using my radio, my footable radio, to fly this aircraft, fly this multirotor. Great. It's very great. At 60 frames per second, it looks realistic. It's really look realistic. I have the feel that I'm really controlling a small multirotor. And the fun part is that it is being stabilized with the PXI, real PXI. It's not a game. Everything is happened inside the PXI, so it's like a real flight for the PXI. PXI has no idea that it is not flying a fake or simulated multirotor. It thinks that it is driving a multirotor. So this is the important part for hardware in the loop. Okay, enough with the game. You can create autonomous missions and any other things that you used to do with software in the loop here as well. You can go to documentation and see what else you can do. You can create a model, you can change the location, you can add the wind, buildings inside Gazebo, and many things. You can change the mode. You see I am flying. Great. Okay, I think that's enough with the Gazebo. Let's put it in the land, return and land. It doesn't matter. Let's finish these things up and go to the next step. And sometimes it has bugs. For example, you see I told the aircraft to land, but you see relative altitude is doing something wrong. It is not landing. It's confused with the relative altitude. I think these are some bugs. I haven't found any solution for that. Sometimes it just messed up and I have no idea what to do. Okay, next step is using jMavSim. jMavSim has much more fun interface, fun environment, and maybe less features, I don't know. jMavSim is much more easier. Just copy and paste this command. It already says the COM port name, the baud rate, and every other things that it needs. Done, and jMavSim environment will be here. You can still connect your QGroundControl again in the background, but I'm not going to do that because right now I don't need it. But for the demonstration, let's open the QGroundControl. You can arm the vehicle even without QGroundControl. Put the throttle on 0 and make a rudder hard over to the right. Your vehicle will be armed. I'm going to arm this time with the radio only. It's armed and now I can fly. Very realistic. I feel that it is really a real small multirotor. Something like a race quad. The lag that you see on the picture is because of video recording, but the frame rate for the simulation is great. Okay, let's touchdown. Everything is on manual. We are in a stabilized mode. We are not doing any autonomous mission here, but you can do it. You can go and set some waypoints and do it on your PX4. This is the path that we went. Remember, you are using a real hardware here. Okay, that's it with the Gazebo and jMavSim. Let's go to the next step and more challenging and more buggy part, which is using Explain. Explain right now with the default options, you can only connect fixed wing planes to that. I don't like the interface with Explain. Explain is the best tool I have ever used. It's great, but the interface with autopilot is not, it's awful. Okay, we come to the section for Explain. You see again there are some manuals for Explain 10, but it still works with Explain 11. I have talked about installing Explain in the last video. Just go ahead and follow them. You have to select some items to communicate with network. Remember, the QGroundControl and Explain are communicating using UDP on your computer. So you have to tell Explain to send and receive which one of the data. Just look at the picture inside the website and select the ones that you need. Number 3, 4, you see it's exactly stated here, such as speed, vertical speed, Mach. Okay, next step is to set the network IP address. Because we are doing everything on the same computers, we should give it the IP address of the local host, and the port number is already stated here, 49005, and the IP 127.0.0.1. This is the IP address of the local host. And the port we receive on the first one, just a random number that don't conflict with the others. And the port we receive on, as you can see as on the picture, it is 49001 and 49002. Next step is select a vehicle. Right, again I'm going to use Cessna Skyhawk in Mehrabad Airport on runway 29 or left. Then the challenging part is here that right now that I'm talking to you on March 2020, the latest version of QGroundControl doesn't have hardware in the loop widget. I don't know why. I'm not sure if they're going to fix it or not. The latest version doesn't have hardware in the loop widget, so we have to download one of the older version. Right now the latest version is 4.0.0. I guess go to Google and find the releases section in GitHub for QGroundControl. Right now the latest version is 4.0.4, but it doesn't support hardware in the loop widget. The latest version that supports hardware in the loop right now is 3.5.6. I don't know about the future. Maybe in the next version they add the hardware in the loop widget again. So I'm going to download the stable version of 3.5.6, and you can refer to the QGroundControl documentation of how to install it. You download the .app image file for Linux, and the tutorial of how to install this is available in this page. Remember, before you run the QGroundControl, you must do these steps if you haven't done yet. You have to run this line chmod +x and the QGroundControl of the newest version. Each version that you install, you have to run this command again for that. After that, you can double click on QGround and open it. Okay, everything is ready. Now we are going to face with some errors that you have no idea. Now I'm going to open the older version of the QGroundControl, which is 3.5.6. It says there's a newer version. I know it, but I don't want it. You see there is a widget item in the top that there's not available in the newer version. Now I'm going to connect my PX to my laptop, and it will automatically connect using serial this time. If you haven't calibrated your radio, you can come here and calibrate your radio. But there is a problem here that when I searched in internet, I found a problem as well. There is something wrong with communicating radio with X-plane. The only channel that works is the throttle. I can control only the throttle with radio control. For others, I'm using the joystick. And the priority is with the radio. If you don't have radio, it won't work. I don't know why. As you can see, I opened the hardware in the loop config in the top left. I just selected X-plane 10 and just clicked on connect and uncheck the first item, which is enable sensor level hardware in the loop. And then click connect, and if the sensors readings are correct, it means everything is okay, so you can continue. If not, close QGroundControl, disconnect PX and do it again to have a nice and decent values. Right now you see there's some problem with the controls. I have put the full throttle with joysticks, but it's not going to full because it's getting the command from the radio. But all other controls are on the joysticks. Only the throttle is being controlled by radio control, my radio controller, and it has the priority. I don't know why. So I put the radio control on the most forward position of the throttle, and then continue the controls with the explain joystick. You see there are some problems. I couldn't even control it on the runway. I don't know why, because I don't know. It goes to disarm position. After a few seconds it starts to roll over and get out of control. So let's start flying in the air. Right now it seems it's working. We are flying over Mehrabad airport and it seems working, but actually it's not. Still the problem exists. I cannot control the throttle with joysticks. The priority is with the radio controller, but radio controller has no control surface on the airplane. I'm using the joystick. And when I'm trying to do some commanded things, for example, want to use the go to command with QGroundControl, it automatically goes to holding mode. I don't know why. If any of you know the reason, please tell me and let me know the solution. I don't know if it is a bug or anything related to that. You see, it's working, but not as I expected. Not as good as software in the loop. You see, when I tell it to go to a special point, it goes to holding mode. And if you want to upload an autonomous mission, remember that you have to add a micro SD inside your PXI because you're using the PXI hardware by its own, so you should have a micro SD on your PXI as well. This is the holding mode, it's doing that perfect, but not doing anything else. Now it's unstabilized and I am flying the aircraft. Okay, that's the point, that's the concept you can use. There's, as I told you, there are some bugs here that I don't know if it is the reason. I don't know what's the reason. If you know the solution, please let me know, and I will update this video for you in the later. And maybe there are some bugs with hardware in the loop PX4 as well as the autopilot. But anyway, this is the capability you have. You can use it in your project if you need it, and if not, just stick to the software in the loop. That may be enough for your project. Okay, thank you very much. I hope this video will be useful for you, and if you need any help in your projects or any comments, please let me know. I will try to do my best to help you. And please like, subscribe, share if you like this kind of videos to motivate this field and motivate me for the next videos. Thank you very much. Happy flying and happy simulating.